Maths with Professor Stats. Da-da. Boom, 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 boom.
Hello, who are you?
I'm a discrete random variable.
Oh, a DRV.
Indeed.
Some of my pupils have just been learning about you.
Have they?
They have, and this week they're going to be learning about your expected value.
Expected? That's what value I'm expected to take.
Exactly. It's a bit like
Oh, the mean.
the mean, exactly. Now, how would you work out the mean?
Well, usually from a group frequency table, I guess we times each data by what its value is, and then get our total and divide by how many bits.
Well, that's exactly what we do here. So, let's give some notation to the expected value, your expected value. So we put
That's
E
me,
bits, and
that's
that's
me.
you, exactly. Now, what you said is we take each piece of data and times it by its frequency, or the value of the piece of data and times it by its frequency. But we only have probabilities here, so what we need to do is we need to times it by its probability. Okay. And then what did you say we did?
We need to divide by how many?
But in the probability that's already been done.
Oh.
So what else do we need to do?
Well, we have to add them up first.
Right, so we add them up. And so the expected value is each piece of data times by its probability and then add them up. Can you remember any other alternative notation for the probability?
Px, P of x?
Exactly, DRV. And so sometimes we might write it like that.
I'm going to go have a look for an example.
Okay, lesson over.
Right, okay, so we're going to look at this problem where we've got a frequency table here. And the first thing we're going to have to do is work out the mean. And we can do that classic stats way, but basically we want to add up everything divided by how many. So we're going to sum of the FX divided by the sum of the frequency. So 10 with 0 to 75 with 1. Let's do that. So that's going to be 10 times 0 plus 75 times 1 plus 10 times 2 plus 5 times 3. And then we divide that by the sum of the frequency. I don't have to add them up because it says there's 100 houses there. Type that in your calculator and you get 1.1. There's the mean. Okay? Right. Now let's draw up the probability distribution. Okay? So let's think what we need in that. We need x and we need the probability of x. And use that notation. Well, x is going to take us its top row. 0, 1, 2, 3. Our probability, these are all out of 100. So like I said, that's 10 out of 100, 75 out of 100, 10 out of 100, 5 out of 100. But I'm going to write them as decimals. So divide by 100, that'd be 0.1. That'd be 0.75. That'd be 0.1 again, and 0.05. Okay, and we've done that, and that seems fine. We've got to use variable x, that's fine. And then we're going to look for the expected value. And we've just seen a formula for that, nice and easy. Expected value of x is the sum of the little x times the probability of x. So what you're going to do is do x times its probability and then add them all up. Okay, well, that's easy. So we're going to have x times p of x, 0 times 0.1 plus 1 times 0.75 plus 2 times 0.1 plus 3 times 0.05. Okay, and then we just with that, and it's 1.1 again. So this expectation of x is the same as the mean, which we wanted it to be. Obviously, you can see why this has happened. Dividing by 100 at the end, same as dividing each one of these values by 100, is giving you these values. It's already been done in the probabilities. Okay, sorted.
Okay folks, so here in this question we've been given the probability distribution and we can see clearly there's two values missing. So if we're going to answer this question and find out the two different values, we're obviously going to have to solve simultaneously. So we need to be able to form two different equations. So in part A, it's asking us to do exactly that. It says, given that the expected value of x is 3, e of x is 3, write down two equations. Now, before we even started this week, we should have been able to write down one equation, because we should already know from last week that these probabilities will sum to 1. So that's what I'm going to do. My first equation I'll form by using that piece of information. So I've got 0.1 plus p plus 0.3 plus q plus 0.2 is going to all equal 1. Well, let's tidy that up a bit. So that's going to be p plus q, and I've got 0.1 plus 0.3 plus 0.2, so that's plus 0.6 equal to 1. Take away 0.6 from both sides, leaves me finally with p plus q equals 0.4. So I've got my first equation, and that, like I said, we should be able to do already. Now for the new bit. Well, we know how to calculate the expected value of x now, so we can do that, and we know it should equal 3, and that will give us our second equation. So if I know that e of x is equal to 3, I know that the value times the probability all summed together will equal 3. So that gives me, for the second equation, 1 times 0.1 plus 2 times p plus 3 times 0.3 and 4 times q, and finally add 5 times 0.2, and all that is going to equal 3. Right, so let's tidy that one up again as well. Well, let's start by doing the 2p plus the 4q, and then sort out these numbers. 1 times 0.1 gives me plus 0.1, 3 times 0.3 gives me add 0.9, and then 5 times 0.2 gives me plus 1. That's still all equal to 3. So 2p plus 4q equals 3 minus, well, if we take all of this over to the other side, that's 1.92, so 3 minus 2. We're taking away 2 from both sides. So 2p plus 4q also equals 1, and that is equation 2 sorted. Alright, so that's part A. I've got my two equations. P plus q equals 0.4, 2p plus 4q equals 1. Finally, for part B, and in an exam they might ask you to do this all in one go without giving you these little breakdown, these little hints. But in part B, it's asking you to find the value of p and q, so to solve these simultaneously. So what I'm going to do is say, I'm going to look for 2p to get rid of it. That seems like the easiest. So I'm going to do equation 1 times by 2. So that gives me 2p plus 2q equals 0.8. We'll call that equation 3. And then to work out the values, what I'm going to do, equation 2 take away equation 3. So that's 2p plus 4q equals 1, take away 2p plus 2q equals 0.8. So that gives me 2q equals 0.2. Therefore, q equals 0.1. Alright, so now let's take that information and sub it in. I'd say the easiest one to sub it into is this, is equation 1. So let's sub it into 1. So now that's p plus 0.1 equals 0.4. Therefore, p equals 0.4 minus 0.1. P equals 0.3. I've got my two answers.
Now we return to maths with Professor Stats. Hello, DRV.
Hello,
How are
Prof.
you doing?
Very well.
What are you looking at?
I'm not sure. The variance, I think.
Your variance? Oh, right.
Bar variance, I'm guessing.
Well, do you remember what variance is all about?
Well, earlier on in stats, it was the mean of the squares minus the square of the mean.
Exactly. Well, if we're looking at a discrete random variable, what are we thinking about instead of the mean?
Expectation.
So, what do you think our formula for the variance is going to be?
Oh, mean of the squares. Expectation of the squares.
Excellent, DRV.
Take away the square of the mean. Oh, mean square.
Very good.
Simples.
Alright, so obviously we've already found what P and Q are. We now know that that's 0.3 and 0.1. Now I'm going to show you how we do the variance of this distribution. So using my handy sheet of paper here. And we know that the variance of x equals the expected value of x squared minus the expected value of x squared. So, the first bits I'm going to do is redraw my distribution, and I'm going to put in a level for x squared, a row for x squared. And then I'm going to put my probability of x equaling x squared. Alright, so I've got my table redrawn, and I know that x goes from 1, 2, 3, 4 and 5. And so obviously x squared will be 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16 and 5 squared is 25. Okay, now that doesn't affect my probabilities, so that's 0.1, 0.3, 0.3, 0.1 and 0.2. So now that I have all my information nice and clearly laid out, I can get to work on finding the individual bits. So the first thing I'm going to do is find the expected value of x squared. So for e of x squared, so I know that that equals the sum of x squared times the probability that x equals x squared. Alright, so that's going to equal for me 1 squared, so 1 times 0.1 plus 2 squared is 4 times 0.3 plus 9 times 0.3 plus 16 times 0.1 and finally 25 times 0.2. So once we crunch that in, that's going to give me 0.1 plus 1.2 plus 2.7, 1.6 and 5. 25 times 0.2 is 5. Alright, so my expected value of x squared, add that all up, 10.6. That's my expected value of x squared. We already know from part A of the original question that e of x is 3. We don't need to work that out. We could do, but we don't need to. So if I know that the expected value of x equals 3, then obviously the expected value of x, if I square that, equals 3 squared. So that's 9. Alright, so now I can just crunch that through my variance. I know variance of x equals the expected value of x squared, take away my expected value of x, then squared. So var of x is going to equal, I've got 10.6 for my expected value of x squared, take away 9, my expected value of x, then squared. So that is going to leave me with 1.6 for my variance.
And now we return for the final in tonight's instalment of Maths with Professor Stats.
What about coded data, Prof?
Well, this is easy if we know something about the expected value of x and the variance of x. So, in this one, our discrete random variable, u, are getting multiplied by a and adding b. Can you remember what multiplying by a would do to the mean?
It multiplied the mean as well, Doc.
It would. And what about adding b?
That would also add to the mean as well, Professor.
So, both of these things are going to affect our expected value of x. So, our expected value of x will get multiplied by a
And add b.
and add b. Well done, DRV. Yeah! What about the variance though?
I remember this. Variance is spread.
It
And
is,
if you-
well done.
Add to all the data, you move it up, but it doesn't change how spread out it is.
So that b is not going to do anything at all.
Uh-huh.
What about the a, DRV?
Well, I think that will times it, but in variance there's some squaring as well. So that might happen somewhere.
So we're going to take our variance of x and it's going to get multiplied by this a. What were you saying about squaring?
Well, variance, if it was standard deviation, it would be fine. But variance, you haven't square rooted yet, so squared.
We need squared. And lots of people forget about that, DRV. I'm very impressed that you remembered. Well done.
Good old DRV.
Okay, so we've just seen that if our knowledge of the expected value of x can help us find the expected value of something like a times x plus b. So let's have a look at this example to see why this works. So we've given a discrete random variable x has the following probability distribution. It says write down the probability distribution for y where y is equal to 2x plus 1. So we need to produce something like this but where we've got y's in place of x's, and this is our link. So, if we draw our table, and we've got x can be 1, 2, 3, and 4, then we want to work out what y is. Well, when x is 1, we've got 2 times 1 is 2, plus 1, that would make y equal to 3. When x is 2, 2 times 2 is 4, plus 1 is 5. And similarly, when x is 3, we'd have 7, and x is 4, we'd have 9. Now, we want to work out the probability distribution for y. So in the last row, we want to fill in probability that our discrete random variable equals y. Well, it equals 3 whenever x is 1. Well, that happens 12/25 of the time. So y would equal 3 with probability 12 out of 25. Well, y equals 5 when x is equal to 2, and that happens 6 out of every 25 times. And in a similar way, this one will be 4 out of 25, and this one will be 3 out of 25. So that would be our probability distribution for y. So, part B says find the expected value of y. Well, we know, we've seen a lot of these examples, all we do is we take our actual piece of data and times it by the probability, do that for each one, add them up. So we'd get the expected value of y is 3 times 12 over 25 plus 5 times 6 over 25, plus 7 times 4 over 25, plus 9 times 3 over 25, so that's 36 over 25, plus 30 over 25, plus 28 over 25, plus 27 over 25. And if you add that up, it comes to 121 over 25, which is 4.84. However, we haven't really used here our link between these things. So let's see if we could have done this a different way. So let's actually work out the expected value of x first. Well, that would be, we could get that straight from this table. So the expected value of x would be 1 times 12 over 25 plus 2 times 6 over 25 plus 3 times 4 over 25 and plus 4 times 3 over 25, which is 12 over 25 plus 12 over 25 plus 12 over 25 plus 12 over 25, which comes to 48 over 25. But it wasn't the expected value of x we wanted to find, it was actually the expected value of y. But we know y is equal to 2x plus 1. So finding the expected value of 2x plus 1 is the same as finding the expected value of y. Well, now we can use this. So we know that this is the same as 2 times the expected value of x plus 1. Well, we know the expected value of x, we've just worked that out. That's 48 over 25 plus 1. So that's 96 over 25 plus 1. Well, that 1 is like 25 over 25. So overall, that's 121 over 25, just like we got earlier. So if we already know the expected value of x, this method would be quicker than this one and would involve less work. But we need to know this first. Right, as we've just seen, we know we can use our knowledge of the expected value of x to help us work out the expected value of ax plus b, and we can also use our knowledge of the variance of x to work out the variance of ax plus b. Okay? Remember that the expected value gets multiplied by a and we need to add b, whereas when we're looking at the variance, it only gets affected by things that are multiplying, not by things that are adding or subtracting. And we have to remember to square it because of the squares in the formulas. Okay, so let's have a look at these 5 parts. So we know that the expected value of x is 4 and the variance of x is 3. So part A wants us to find the expected value of 3 lots of x. Well, using this, that would just be the same as 3 lots of the expected value of x, which is 4. So 3 times 4 gives us 12. Part B. Well, if we want to find the expected value of x minus 2, well, that's just the expected value of x minus 2, which is 4, take away 2, which is 2. Right, part C. The variance of 3 lots of x, well, that's like 3 here, and so that is the same as 3 squared times the variance of x. The variance of x is 3. So that's 3 squared times 3, which is like 3 cubed. That's 27. Part D. Now this is the tricky one that catches people out. Subtracting something just shifts the data. It doesn't change how spread out it is. And so that doesn't actually affect the variance at all. So the variance of x minus 2 is exactly the same as the variance of x. We can see that from this formula. B doesn't affect it at all. And A is like 1 in this case. And so that would just be the same as the variance of x, which is 3. Now, part E is a bit trickier, because it doesn't look like it refers to either of these. And this is where we need to remember something from earlier. let's recall that the formula for the variance of x is equal to the expected value of x squared minus the square of the expected value. Or we can actually rearrange that equation to make the expected value of x squared the subject. So let's do that. So we get the expected value of x squared is equal to the variance plus the expected value all squared. Well, we know both these things. We know the variance is 3, and we know the expected value is 4, but then we need to square it. And our knowledge of bid maths says that we do the squaring first, then add 3. So 16 add 3 gives us 19, and we're happy. Maths with Professor Stats. Hello, who are you?
I'm a discrete random variable.
Oh, really?
And why wasn't it in posh?
Oh, stay in character.
I don't know what my character is yet. I haven't got it in my head.
Perfecto.